LeetCode Daily Challenge I was not able to do. I've been on a down streak recently. I think I failed like 5 out of the 6 previous daily challenges. I don't know what's going on. I mean, I think there's a gap in my knowledge. I think I'm very good at some things and I'm okay at other things. I guess like with anything, right? That you have strengths and weaknesses. And I guess this week we're just hitting a lot of the stuff that I don't have a lot of like experience with or practice. And this problem that I'm going to go through, I had to look at like many solutions and watch some videos. And the solution isn't something that is new to me, right? All the tools that are used to solve this problem are in my bag. But to get to a solution is not very obvious. And there are some like observations that need to be made. And I'm really bad at making those observations. So, with that being said, I'm just trying to document my progress. This is 2551, put marbles in bags. So we're going to be given like a bunch of marbles, and each marble has some weight, right? So in this first example, they give you 4 marbles right here, and they all have their different weights. We're also going to be given a K, and a K is basically how many bags they want you to put these marbles in. For example, we could put these marbles in a bag, and then we can put these marbles in a bag. So there's one thing that they say, if you pick like the index I to J, that means all the marbles in between the indices from I to J need to belong in that bag, right? Like we can't pick what that means is we can't pick like one bag to be like this and then another bag that skips over and goes like this, right? That's not allowed. They need to be contiguous. And then so there's a cost or like a score, or no. There's a cost of each bag, and the cost of each bag is just the weight of the beginning. If this was a bag right over here, we take the cost of the beginning one plus the cost of the last one. And then it's possible that I and J are the same. So there's like one marble in a bag. You would just need to do 1 plus 1 to get the cost. So it's okay to like double count in that sense. So there's like a lot of setup so far. I'm just talking about the setup. And then the score is the sum of all of these costs after putting all the marbles in K bags. So you see how there's different like groupings that we can form, right? Like if we only had 2 bags, we could, this is one possible grouping, right? Another possible grouping is this, like just 2 and 2. And then another possible grouping is this and this. So you see there's like many different groupings. I think, okay, and then finally they want to return the difference between the maximum and minimum scores amongst the marble distributions. So to tackle the problem, the first observation that you need to make is that when they want 2 bags, that means they want like a split, right? And we know that like the first and last of the array will always be in the answer, right? Because that's where we have to start. So this is going to be like the starting I. And then if we split right here, this is going to be the ending J. And then this is going to be the starting I as well as the starting J, right? And then if we were to calculate the score of this, we would have to take we'd have to take 1 plus 5, right? Because we take the starting and ending plus 1 plus 1, right? Um, Similarly, if we were to do I and J right here, or yeah, if I and J was right here, that means we split down the middle and then we have an I. So you see how like every time we have a split, these two numbers will always be in our sum. in our score, right? As well as always the first and the last, because we just need to distribute all the marbles. So the first element and the last element will always be in the score. So for this one, if we did a split down the middle, it would be 1 plus 3 plus 5 plus 1, which is 10. Um, okay, this is 5, 6, 7, 8. That's 8. And then let's do one more split. Let's do one more split over here. This means this is the ij, this is the I, and that's the j. And that would look like 1 plus 1 plus 3 plus 1, which is 3, 4, 5, 6. 6, right? And then out of all of these are like all the possibilities that we could have created. We just need to take the max score, which is the 10 right here. So we do 10, and then we just take the min score, which is 6. So we do 10 minus 6 is equal to 4. So that's our answer. And then very important that we observe that whenever we make a split, we always add the like ending of one section and the start of the next to the score. So there's a there's some like observation that we can make there, is that we could just run through all of these pairs and just add the sum, like 4 up, assuming that we put a split right here. That's what it means, right? And then 3 and 5 is 8, again assuming that we split right here. And then 5 plus 1 is 6, again assuming we made a split right there. And if we just like sort these, okay, well, so after this is how many splits, right? It depends on the K. If there are 2 bags, that means we need 1 split, right? We need K minus 1 splits. Basically, we just need to choose K minus 1 of these, and that would be our result. So if we wanted to find like a max score, well, one thing we can do is just take all these scores and like sort them. So the max score will be like the last K minus 1 splits. So it would be like 8, right? And then for the minimum score, it would just be the first K minus 1 splits. So it would be right there. And then you see that this is the max and that's the min. So 8 minus 4 is equal to 4. And that's exactly what they want. And then one thing to observe is that if you did the math out, you'll see that there's some missing scores. It's just because it's the first and the last that will always be in the max score and the min score. So when we do the max minus the min, we're really kind of ignoring this, because let's just say we had a max score that adds the first and last, right? Because that's always got to be there. And we subtract it by the min score, which always has the first and the last. You'll see that the first and last actually just gets canceled out. That's why we can just do max minus the min. But yeah, so the first thing to do is to make these like pairs, right? So I guess pairs is this. Then we can just do like for I in range, the length of the weights, minus 1, because we want to do our current one. We want to process the current one and its neighbor. So we just don't want to go out of bounds. So we'll just do pairs dot append the weights at I plus the weights at I plus 1. Right, so we're just adding all these in. Pairs dot sort. So after we sort the pairs, we could do the max sum is equal to 0, let's just say. Min sum is 0. the first k minus 1. So for I in range k minus 1, is that how it works? You just want to take the first k minus 1 of the beginning. So the min sum plus equals pairs at I. The max sum plus equals the, we want the length of the pairs, right? Let's just say n is the length of the pairs. So we just do pairs at n minus 1, that's the last element, minus I. Right? Then we just need to return the max sum minus the min sum. And that's the difference of the maximum score minus the minimum score. So like in retrospect, for me, I mean, it's a very tricky problem, but like the code isn't bad at all, right? It's just getting to these observations is very tough. And yeah, that's about it. Just a short video. I did not come up with this on my own. Had to really dive deep into this and watch solutions. But hopefully, like, um, it gets better from here. Um, but yeah, thanks for watching.